Thank you, everyone, for coming to our session. My name is Martina Ilieva, and I'm a partner alliance manager in SUSE, focused on our ISV partners. And today I have Madhuri from Aloto with me. She is the founder of the company, and we're going to talk about the collaboration between our companies, about SUSE AI certifications, and we are going to demo how you can dynamically manage the GPU assignments with a Aloto solution on SUSE AI. So, Madhuri, introduce yourself.
Hello, everybody. I'm Madhuri Echuri. I'm the founder of Inodal, makers of Nodeless Kubernetes, and super excited to be here. I know it's probably the last session of the last day, so thanks for showing up. So, Martina, I'm curious, what was your first interaction with AI?
Well, my first interaction with AI was many, many years ago when the two giants, Reuters and Dow Jones, made their joint venture. So imagine imagine these huge databases of news from all over the world, and they all need to be very carefully categorized based on their content, each news. So the aim of our project back then was to train a system, auto-coding system, a software, to categorize all these news correctly. Why? Because all the customers and the subscribers of Dow Jones and Reuters, they needed to receive the information that they paid for, whether it's specific industry analysis or forex exchange market or the latest merger and acquisition news. So the project was a great success. We freed up a lot of resources, removed these tedious, repeated tasks, and at the end of the day, all the manual coders, indexers, as we called them back in the days, they turned into due diligence analysts. So in order to do that, in the past, we used a lot of statistics, and back then the focus was on stochastic models, similarity matches, confidentiality level indices. And now we have, the situation is completely different. We have the LLMs, we need much more compute power to make it happen. We need the GPUs, we need to optimize the usage of GPUs because they're where we made the investment. And if I have to compare the concerns that the CTOs and CIOs had back in the time and now, they're more or less the same because they all want innovation, optimization, and cost efficiency. Madhuri, when was your first interaction with AI?
Yeah, my first interaction was about 12 or 13 years ago when I was working at VMware on resource management, and we used AI for right-sizing applications' resource requirements. So the operator might think that, oh, the app needs 2 GPUs and, 2 vCPUs and 4 gigs of RAM to be happy, but the app might actually need much less than that. So we were right-sizing application resource requirements, but this was like the 0.1% of the 1% of the top tier enterprise customers. So it was for the super, super high-end customers. With the advent of LLMs and Gen AI, it's super exciting to see it come across, the goodness of AI come across for majority of normal day-to-day use cases across SMBs and large enterprises as well. So having said that, there is a lot of hype around AI. Even if you want to escape it, you cannot escape it. So Martina, is there budgets? Is there a budget for AI in companies, or is the hype just a hype?
Right. The budgets are out there, and there are a lot of statistics around it, a lot of information sources and stuff, but two important things. Last year, there was a considerable jump in the AI market growth. The jump was of about $50 billion US compared to the previous year. And the projections are stunning. The market is expected to grow from about 200 billion for 2025 up to 1 trillion for 2030. So the companies are going the budget is the budgets are out there, and now is the time for execution, and now is the time for optimization. So the companies are going to pay much more closer attention who they are partnering with, and the significance of the AI certifications will rise as well, because the software, when you have the ISV software certified and secured, that of course increases the credibility. It means that it works, and it provides you access to the enterprise customer database, base, and it drives growth. So the budgets are out there. Madhuri, where do you think they're going to be spent?
Yeah, so like we talked about earlier, Gen AI has made it feasible for all kinds of enterprises to adopt AI technologies really quickly. So the budgets are going to go into verticals in healthcare, in data, in climate tech, these kind of science and technology players where there is a need for AI enablement, but there is no headcount for building MLOps teams. They don't even have the interest in building MLOps teams. Like I was talking to, was it Ricardo from Child Health Coalition, who's been on the keynote stage a couple of times this week, and he was saying that they have so much proprietary data, and they would love to do data-driven machine learning techniques and get insights out of it, but they don't have the interest or the headcount to actually build out these MLOps teams. So these kind of verticals that are not tech forward verticals, that tech is just an enabler for their core business, those verticals would be the first early adopters. So these are computer vision, some of the things that Martina called out, robotics and NLP and genetics like biosciences, etc.
Right.
Go ahead, Martina.
Yeah. You can see, in order to see where what the enterprises are looking for, we need to look at three things: the AI use cases, the market challenges, and the day-to-day technical life of the engineers. So when we say AI use cases, these are all the things that the AI can do across the verticals that Madhuri mentioned. And if we take, for example, my favorite example is the computer vision with its specific facial recognition, object detection, and image recognition. At the end of the day, it comes down to the real scenarios of medical anomaly detection, agricultural monitoring, and manufacturing fault detection. And another example is robotics with its specifics, automation and quality control, and the real case scenarios that the user can feel and touch are manufacturing automation, retail service robotics, and those hospital automation of non-patient facing tasks. So about these are the use cases, but we all live in the real world with the market challenges and what we identified in SUSE. And probably you heard that throughout all the keynotes and stuff, but these are the four main challenges that we have. And when we say security threats, what we mean is that the AI security threats that every enterprise need to monitor and protect against, like data poisoning attacks, prompt injection, and misuse of model outputs. When we say regulatory compliance, we mean for us, it comes from the interest of the companies with auditable use cases, because they need best practices, they need guidelines and templates to prove that they're compliant. For the complex infrastructure, I bet that you all know that all the AI deployments are blend of software, hardware, storage, all the systems that need to work together. To manage with all the challenges, we are partnering with different types of companies for regulatory compliance. For example, now we are starting a partnership with a company which is specifically focused on the European AI Act to handle the complex infrastructure issues. We're partnering with the with the global system integrators, with the regional system integrators, etc. We cannot do it alone. And the rapidly changing tools, we all know that every month, every week, every day, there are different AI components coming out. So when it comes to the real technical life and what the platform owners and data scientists and the engineers need, they all want one platform, one ring to rule them all, right? Easy to install, easy to configure, easy to take some components, to combine them. They want the latest versions, etc. And they want that because they need to tackle all the user stories at the end of the day that they have around optimization, security, the agentic workflows, and customer experience. So, Madri, tell us more about the models that are going to be used in the future, and what are you're talking with a lot of partners and customers.
Yeah.
What are your observations?
Yeah, so we talked to a lot of large enterprises as well as smaller SMBs that are interested in AI adoption and that have the budgets. So in 2024, 2023, when OpenAI came to market, everyone was excited about consuming OpenAI. So the first vertical or the first function inside a large organization that was adopting OpenAI or Anthropic was the SDR, BDR functions for sales engineering and for sales function requirements, because most of the time you are composing emails and you're sending them out in an email blast or a marketing blast, and it's pretty easy to automate. So here is an example from a Fortune 100 CIO. They started using OpenAI to auto-generate emails for cold outreach. OpenAI generated really nicely formatted email with bullet points, and it was costing them 7 cents per email, which was much cheaper than hiring a BDR or an SDR function. So they were really happy with it, but they realized that open source models were not up to the standard last year and the year before, but they had a lot of security concerns about the internal customer data going out to a public hosted proprietary model. So towards the end of last year, this year, public models are at par performance-wise with the proprietary models. That, along with the security concerns of leaking your customer data to an external hosted proprietary model, that is the trigger for people to start thinking about self-hosted models. So why don't we run models, the public models, which are good enough, inside our own data center or inside our own VPCs? So self-hosting for this CIO, it's going to cost her 1/100th of the cost per email as compared to OpenAI. But she chose at the end of last year in Q4 to continue to use OpenAI because OpenAI generated this nicely formatted with bullet points. But she plans to move to self-hosting this quarter because public models are up to par with generating nice emails or nicely formatted emails. So cost is one reason for using for self-hosting. The second reason is security. You don't want to leak your data to a proprietary model sitting in someone else's data center. And also, what was stopping people from self-hosting was performance. And with the public models maturing at a really fast rate, performance is no longer a blocker for self-hosting. But most enterprises don't have the interest or talent or even the time for executing their AI initiatives if they have to build out internal MLOps teams. And make these decisions that change on a month-to-month basis as to which model should I use and what should I use for observability, what should I use for security guardrails, etc. So this is where folks like SUSE are super exciting, because SUSE AI is making that decision for you, and it's coming from a trusted vendor with a huge amount of respect in the market. So Martina, please tell us a little more about SUSE AI and how it's going to help these companies.
Right. So SUSE AI is our cloud-native open infrastructure platform for running and deploying Gen AI workloads. It's fully integrated with different components that you can pick amongst. You can build your AI applications based on your user case, based on your use case. So what the platform provides, it's zero trust security, which for us is end-to-end vulnerability scanning and management, and also observability to tackle the compliance topics. So in SUSE AI, the most let's say differentiating criteria for us is that we are embedding all the features from SUSE AI security and SUSE AI observability. And you see, we have AI library where you can pick up the components that you need. When we say security, we've got all the different layers of security, like authorization, authentication, the secure communication between the clusters, the secret management, the cluster hardening, everything. And when we say observability, what we observe and what we are announcing now with yesterday, Abhinav, the VP of SUSE AI, is all around the SUSE AI observability, where we look at the AI component dependencies. We visualize the models, the databases, the dependencies between them. We also look closely at the GPU utilization, and here is where Madri and Telotel are helping us a lot. And we're observing the whole workload distributions. So in terms of partnerships, we're partnering with various companies for different use cases. That is, we're starting to build an ecosystem of partners to tackle the different use cases. And not only that, we are providing also right now blueprints, where we call them green docs, how to implement everything step by step. And exciting big partnership with Microsoft, as you saw, with the Infosys, etc. But we are also focusing on much smaller companies, ISV companies, and that's where these AI certifications come into play. We have and there is a bunch of technical sessions and recordings if you want to go deeper into the SUSE AI specifics. What we have here now is the SUSE One Partner Program. Why we created that program? Because 90% of all SUSE sales are through or with a partner. And in 2020, SUSE brought together all the different scenarios of collaboration and created one framework, the SUSE One Partner Program. Under the program, we have 6 different specializations. Each one is for a different type of partner. One partner can be part of more than one specialization. Innovate is our specialization for hardware and software certifications and collaboration with partners. This is where SUSE AI fits. Then we have Sell for all our channel partners, value-added resellers. We have Solution for the OEM and embedded solutions. We have cloud for the managed service providers, and service for all our subcontractors, and train for the companies that we're doing trainings with. So SUSE AI is under Innovate. We have two certifications under SUSE AI. One is SUSE Ready for AI, and the other one is SUSE Certified for AI. SUSE Ready for AI is a partner-led certification. It means that it's a self-verification certifications. You need in general, you need to test that your solution works on RK2, our Kubernetes distribution, and then you add that into your documentation, and we can add you as a partner in our partner certification catalog. Then the next step for SUSE Certified for AI, it's a certification where our engineering team is involved, and you receive NFRs, you test your software on SUSE AI, and that's how we proceed. So these are all the benefits, and of course the main benefits is that being part of SUSE One Partner program gives you access to all our other partners, gives you access to deal registration, gives you access to discounts, to different joint go-to-market activities, etc. Here are some of the partners we are starting with in this AI journey, and the list will grow. Now we'll focus on what we are doing with Aloto and how they're helping us with the GPU assignments. Madhuri, tell us more about it.
So one of the first questions that people have when they're thinking about self-hosting is, hey, how is my GPU cost going to impact my AI budget? Because GPUs are super expensive and in short supply. So it's the first objection or consideration people think about when they think about self-hosting. And that is where we come in. So we have been around for about 8 years. So we are the creators of Nodeless Kubernetes. Have you heard of Nodeless Kubernetes? So Nodeless Kubernetes is fundamentally this idea that compute should be commodity. Your applications have moved from being treated as pets to cattle, but your compute is still treated as pets. You're hand creating your node pools and your compute shapes for your Kubernetes clusters, and you are constantly trying to monitor what are the different compute shapes available on each cloud provider, what is the spot instance shape, and what are the different hardware silicon types, and should I use an NVIDIA GPU versus an AMD GPU, etc. So the idea of Nodeless Kubernetes is you as the consumer of Kubernetes, which has standardized platform across on-prem and public cloud, you shouldn't have to worry about what are the different compute shapes that are being consumed under the covers. So Nodeless Kubernetes is this concept that you think of your cluster as a deconstructed compute pool where your compute comes up and disappears according to the application lifecycle. So if your app comes in and it requires resources of shape X of amount Y, that resource of the shape X and amount Y is going to be provisioned in the most cost-effective manner when the application starts and terminated when the application terminates. So think about it as a deconstructed cluster. And why is this useful for AI workloads? Because GPUs are expensive. So you do not want a GPU compute node that's provisioned, that's burning your cloud bill without running any workload. And secondly, GPUs are also in short supply. So just in time, right-sized procurement from the right region, from the right cloud provider is going to make sure that your application SLAs for your, whether it's online inference or batch inference, any of this AI work streams, your business SLAs are not impacted because you're waiting for a GPU to be available in a region and you're out of capacity in that region. So this is the TLDR of what Nodeless Kubernetes is. So Nodeless Kubernetes has been GA on every major cloud providers, Kubernetes distro, EKS, GKE, AKS, and Oracle Cloud OKE as well. And it is battle tested on all major compute shapes. So where we insert is SUSE AI. Since SUSE AI chose Kubernetes as its fundamental substrate for running all the AI workloads, we insert ourselves into at the Kubernetes layer. So by inserting Elotal into the Kubernetes layer, you are making sure that you're paying exactly what you use with respect to GPU cost, and GPU scarcity is not impacting your business SLAs. I'm going to pause here to see if it makes sense before going into a demo. Yep.
Question. With this right sizing Kubernetes, this range of pride, does the interface know, is it tied in? So did you guys use these sections? Or is it you guys have your own dev for custom?
No, we intentionally did not build dashboards because we are an infra scheduler, and we want to work with whatever dashboard the customer chooses. In fact, in the demo, we use Rancher Prime as the dashboard. So we don't have a dashboard. It is simply a stateful set that gets deployed onto your Kubernetes cluster, and that's about it. There is nothing more to it here. It's a webhook and I think one or two pods associated with our deployment. That's about it. Does that answer your question?
Yes.
Yeah. Any other questions? All right, let's look at the demo. So what we aim to see in this demo is we have SUSE AI stack up, and we are starting with 0 pods in the OpenWebUI Olama deployment. So what we want to show is when you have no user workload running, no user load landing on your system, your OpenWebUI Olama replica set has 0 pods in it. If there's 0 pods, then your GPU utilization is 0. So you're not spending for any GPUs. Then we aim to scale the Olama replica set from 0 to 1 pod, and we'll see just-in-time right-sized GPU come up. And you'll be able to use your SUSE AI from the chatbot UI, and you'll be able to get responses. And then we will simulate user load increasing. So the replica set scales from 1 pod to 2 pods, and then we will see the second GPU come up just in time. And then we'll do the reverse of it. So we'll scale down the load, and you should see the GPUs once the underlying GPU has 0 pods running on it, the GPU is automatically terminated by load. Does the workflow make sense? Yeah. So here, this demo was created by my coworker, Justin. So here, what we are seeing is there are no models to choose from because Olama deployment has replica count set to 0. So there are no models. So this simulates the user load being 0. So if there is no user load, then you're not seeing any. Models. So this is the Rancher UI, Rancher Prime UI. I think that was your question too, right? So this is the Rancher Prime UI, and this is the EKS cluster with Luna and SUSE AI stack deployed on it. So what we want to see is when the system is idle, you only have 2 system nodes that are part of your EKS cluster, and you do not have any GPUs running on it. So this is Luna managed node for non-GPU workloads and 1 Kubernetes worker node. So let's go ahead and look at our OpenWebUI, OpenUI Olama deployment and scale the replica count from 0 to 1. So when this replica count is scaled from 0 to 1, what happens is Luna detects that this new pod has landed. Elotal Luna detects that the new pod has landed on EKS cluster. It looks at this pod's requirements and provisions the most cost-efficient right-sized GPU for the pod. And this GPU node is provisioned just in time, and it is a regular kubelet worker node, and it attaches itself to your EKS control plane. You see the new compute node here. it attaches itself to the EKS control plane and gets earmarked as, hey, Kubernetes scheduler, do not schedule any workloads on it except for this newly provisioned pod. So once the compute node is available, the pod is scheduled by the Kubernetes scheduler to the compute node. And if we go back to the SUSE AI screen, we see that the models are available. And if we ask a question, we should get a response. So the next part of the demo is we want to simulate an increase in the user load. So let's say instead of one chatbot user, you have 20 chatbot users. And this needs the Olama replica set to scale from 1 pod to 2 pods. So once we scale the Olama replica set from 1 to 2 pods, Luna detects this new pod landed, and again, G4DN node is provisioned, which is the right-sized, most cost-effective node available to your account at that point in time. And this node is attached to the kubelet, to the Kubernetes control plane. It's a regular kubelet worker node, and the second pod in the replica set is scheduled to this newly provisioned GPU node. And if you see, once the node is available, you see the container creating for the second pod, and you have two pods that are available. So you should see an increase in the performance. If the user workload increases, you should see better latency numbers and user happiness SLA scores as well. So what we would want to do next is we want to simulate a decrease in the user load. When the user load decreases, the Olama replica set is scaled down from 2 pods to 1 pod. So when the second pod is terminated, the second pod's underlying GPU node is idle. So Luna detects that this GPU node is idle, and the GPU node would be cordoned off, and it would be deleted and automatically terminated. So what you're getting is you do not have to figure out, hey, what are the various GPU shapes available to my account, because cloud providers bring better, cheaper GPUs to market at a very high cadence. What is the right shape of GPU? What is the right price point? For example, you might be open to a Spot instance, which is at a much cheaper price point, and Luna will automatically provision a Spot. And if you're out of capacity for Spot, it'll switch to on demand. So it'll make sure that the node appears, the node is commodity, the node is cattle. It's not something that you have to pay attention to. Does this make sense? So what you would be getting is, from a cost point of view, you're paying for exactly what you're using instead of paying for what you think you might use. And in addition to preventing wasted spend on GPUs, you're also getting better SLAs for your end user for the SUSE AI, because with the increase in user load, you're not waiting for an unavailable GPU shape to be available in your region in which SUSE AI is running. So that is also a huge value proposition. So we were very curious to explore go-to-market with SUSE AI, because we are an infrastructure scheduling team. We've done scheduling for decades. We are not interested in building all the enterprise-grade observability, security hooks, and all of that stuff, and we don't have a dashboard. So we were very excited to work with SUSE AI to get certified, and it was super easy to test both the products together, because Luna gets deployed on any Kubernetes cluster. So it was super easy to test Luna with the SUSE AI stack, and the team was awesome to work with. So it was a very smooth and quick process for us to get certified. Thanks, Martina and the team, for helping us get certified. So to summarize, AI budgets exist, and the public models, open source models, are performant. Starting this year, they are at par with the proprietary models. For security reasons and cost reasons, self-hosting totally makes sense. enterprises do not have budgets or the time to build out MLOps teams. So end-to-end AI stack that comes out of the box with all the bells and whistles is the way to go. And that's where SUSE AI comes in. Cost and business SLAs are the reason why Elotrel would fit into the SUSE AI stack. So Martina, how would one get access to SUSE AI?
Right. So the steps are come to me, talk to me. Let's join SUSE One Partner Program, test your software with SUSE AI, and let's go to market together. Thank you.
Any questions? Yeah.
I did some kind of a price slicing.
Yes, yeah. So we do GPU time slicing. GPU time slicing is great for dev test scenarios because the sharing of the resources is for production. You might not want to do that for application performance reasons, but we do recommend turning on the GPU time slicing feature for dev test environments, and our product does that automatically. So that's one of our value propositions, is we take care of making sure the underlying compute is the most optimal configuration for your business SLAs. Thank you for asking that question.
I think that's also remember also SUSE AI, so we can really do it through the app.
Right. Yep. Absolutely.
Yeah. I'll we have a blog post on GPU time slicing. I'll share that with you. Yeah. Okay, doc. Any other questions?
Can you do it not only GPU,
Yeah.
but just normal?
Yes, yeah.
So sometimes, yeah.
Yes, yeah, for sure. So we do every compute shape. So this vision for deconstructed cluster is to commoditize compute of all compute shapes, right? So we do CPU, ARM, AMD, all kinds of compute. Actually, in 2019 or 2021, KubeCon, I had a talk where we did a demo for Kubernetes for Mac. So we even do Mac, so any compute shape.
So you just look at how the node of the constellation, like label it, or or how it technically works. Like you look at the labels.
So we look at the application's resource requirements. So if the app says I need, you can ask for CPU, memory, network IOPS, storage IOPS, or a GPU shape. So depending on the app's resource requirements, we look at, because our product runs inside your cloud account, right?
Okay, you take from pool the.
Yeah, so it'll look at the resource requirements, and it'll look at what are the shapes available to you. It does take into consideration if you have reserved capacity, things like that, and so it'll look at what is available at runtime and provision the right shape. And that's a really good question, because AI systems are not GPU only, because you have the data pre-processing, data ingestion, data post-processing. They would run on CPUs. You don't want to spend an expensive GPU on those kind of things. So the GPU component is not running in a siloed environment. You'll have all this constellation of applications that are either ingesting or consuming or sending data into the CPU component. So all of these other components will automatically run on the cheaper GPUs. We do ARM. We have a couple of blog posts for ARM on Oracle Cloud. Yeah. Does that answer your question?
Yeah, thank you.
Yeah.
Shit. Thank you.
What do you do at SUSE?
So I'm working with a customer who's for running AI workload. You have a huge data center,
Right.
and they have the issue also, like need to quickly provision the provision nodes.
Right.
It's interesting idea there.
Yes. Yeah.
Because they have large data center.
Right.
These very expensive ones.
Yes.
So and beyond to they serve for several customers as well.
Right.
So and they need to split and say, okay, this customer using this workload at this moment.
Yes.
Enough the nodes.
Yeah.
Do it. So at the moment they're doing with the open scheduler.
Right.
But if it's automatically paid,
Yes.
you should look at
Yeah. So we are the scheduling team, the original scheduling team at VMware. So we did bin packing of scheduling for on-prem data centers at VMware, and we've been in scheduling for decades, literally. So that's what we do, and that's why we're not building UI or anything. That's not a. I would suck at building a UI. uh,
But if it's not used a lot, so you need to
right.
need to know
Yes.
the best case.
Yeah. And we kind of do smart optimization there. For example, the Mac Metal nodes on AWS, they are charged at a 24-hour cadence. So even if you provision and deprovision in an hour, you're still billed for 24 hours. So we take all of those constraints into consideration. So what we do is if something is provisioned on a Mac and it's terminated, we keep it around in case something else might need it for 24 hours. So
Fishing
yes.
it's already been built.
Yes. Yeah. And we've been around for 8.5 years, so it's all production.
But it's not only on the cloud you oriented, so I can do it on the local data center as well, right?
Right. For local data, so there are two parts of the product. First part works on a single Kubernetes cluster, and the second works for a fleet for AI/ML workloads. So for on-prem data centers, for the single cluster, we're waiting for a customer use case to add the automatic provisioning on KVMs or any other substrate that the customer chooses. So we have, yep.
We have a choose your authorization, so
SUSE virtualization. Yes. Yeah.
offices virtualization.
Yeah, we'd love to. Yeah, it'll take us a month of engineering effort, so we would love to do that. Yeah.
I will connect.
Yes. Yep. Yeah. Thank you. Any other questions?
Okay, doc. Then thank you.
Thanks for showing up, and hope you had safe drive or flight back wherever you came from.